From Worldwide Technology, this is the AI Proving Ground podcast. Today, two important breakthroughs you may be unfamiliar with: Model Context Protocol and Agent-to-Agent Communication, and how they are quietly rewriting the rules of enterprise AI. On paper, they're just standards. One shapes the data an AI can see, the other lets teams of AIs work together and hand that data back and forth. But in practice, they decide whether your customer bot can tap into a real-time inventory system or whether a factory robot can talk to a quality control camera without tripping over compliance rules. To understand why this matters and what happens when hundreds of these servers and agents light up inside a single company, I sat down with Sally Jankovic, an ML Ops engineer, and David Geddam, a senior AI advisor. Together, Sally and David justify why as AI systems get smarter and start making decisions by themselves, why we need new rulebooks like MCP and Agent-to-Agent, and what problems they actually solve, both today and in the future. This is the AI Proving Ground podcast from Worldwide Technology, everything AI, all in one place. Let's get to it. Hey, Sally. Hey, David. Thanks for joining us today on the AI Proving Ground podcast. How are the two of you?
Good.
Excellent. Well, 2025 has been billed the year of Agentic AI, and two methodologies started to emerge. We've been hearing a lot about it on previous episodes of the AI Proving Ground podcast, and that is Model Context Protocol, MCP, or Agent-to-Agent Protocol, A2A. Sally, real quick, start us off in case some of our listeners out there aren't familiar with either of those terms. What is MCP? What is A2A? And why is it important to understand it in today's somewhat chaotic AI landscape?
Right. Okay. So, they're both different forms of standardization, basically. So the high level you can think about is how do we standardize how agents, and by agent, we mean an LLM that has access to other tools, including APIs and that type of thing. How do they integrate into, environments and interact with objects? So MCP deals with when you think about the objects the agent is interacting with, it's those tool calls. So it's a way of standardizing how your agent plugs into a specific tool in a way that is modular and reusable. So it was developed by Anthropic, and I believe November 2024 it was released. Since then, it's taken off. But essentially, the reason it's taken off is once you write an MCP server, they're called, that's an integration of a tool into your agent, you can repeat that with other agents. And so it's just a really nice modular way of plugging in tools. And also this means that it's a lot easier to always know how your agent is going to take in a tool if it's always in MCP format. So, go ahead.
Yeah, and David, tell me about how they work together, if at all, and what it enables the end user or the end client to do.
Yeah, so it's interesting. I was actually looking at the history of MCP, right? And before MCP, what people were doing was, when they were chatting with LLMs like the ChatGPT, they would start adding context into the things like, hey, I had a conversation 2 weeks ago or 2 months ago about this. These are some of the other events that happened. By the way, can you make a better sense of this? And that's where the whole context aspect started to get designed. And one of the other pre-MCP was the language server protocol, where these are the coding assistants that you're hearing about, right? How do they complete a coding sentence? Oh, because they're reading all the programming languages and they know how to construct it. And then therefore they know what the user is trying to do with the code. And that's kind of where the MCP, at least that's a history. And so going back to why MCP and where I came in was, how does MCP and A2A start scaling the transition to agentic AI and physical AI, right? How does this work? Because right now everything was about generative AI. So that's where the connect is. So MCP is standardizing information, as Sally mentioned. But the second part of that equation is how does the agentic take advantage of that standardization? And so that's where the agents, if you design it properly, are able to rationalize it, reason, and be able to come up with autonomous decision making. And that's kind of where the agentic or the A2A protocol starts to take over. So anyway, that's kind of my feedback.
Yeah, Sally, how does A2A start to take advantage of that standardization, and what is the value of that?
Yeah. So, I mean, David did a great job of setting it up. A to A is very similar in some ways to MCP. It's not something that hasn't been done before. It's just being done in a standardized way. So, someone who has a bunch of different agents working on different things, say one agent is helping, customers, and then another agent is on the back end, sort of like the Atom AI we have at WWT, and for some reason you want them to talk to each other, or one has a task that it might pass off to the other, then the A to A protocol basically standardizes how those two agents would interact with one another. You might have a third agent, your sort of head agent, that you could talk to and say, hey, get this data from that agent or get this data from that agent, or have those two agents pass data from one another. So again, many engineers listening to this will think, oh, I've had a setup like that before. This is just the way to standardize it.
Yeah. Appreciate the mention of Atom AI. Just for those out there that may not be familiar, Atom AI is WWT's AI chatbot that we have on WWT.com. It's available for all of our internal WWT users as well as our external registered users. So you could, as you're listening to this, go out and even type in at WWT.com, what is MCP, what is A2A, and see what you get there. David, Sally had mentioned that some of these methodologies, while being used for a while, really started coming onto the scene just recently. I think you said November 2024, at least for MCP. Does that mean that it's just now getting integrated into an enterprise setting, or how are enterprises adopting these technologies?
I think that because of the kind of the starting, like generative AI has become such a kind of natural way in which people are interacting with it. Now, this is a natural advancement of that, and how do you take that natural advancement and scale it, right? And with the push of NVIDIA with the agentic and the physical, it becomes very, very interesting. I see the MCP becoming the brain of the agentic aspects. Right now, we're looking at maybe task, automation, right? Like, so if you had a customer service, it's a customer service that's trying to automate, let's say, somebody calling you and trying to schedule a travel or looking at booking your tickets or things of that nature. Can I automate that? Well, let's take it a step further. And now let's start to look at real-time systems that actually work in an assembly line or robots, right? How do you think MCP could work in that in a real-time sense? And so this aspect of how MCP is designed and the scaling, I mean, if you just look at the Meta and the OpenAI releases, they are talking about thousands of MCP servers running synchronously to direct information into the engine so that tasks can be automated. I mean, that's significant. So I think it's a natural state of scaling, and that's what I'm really interested about. And that's why I started looking at MCP.
Yeah, Sally, looked like you wanted to jump in there for a second.
Oh, I was just sort of agreeing, well, with David when David said it was like sort of a massive thing. It's both massive from like a results perspective, and then also like what that scaling looks like, right? Like, I think that's a really important question to ask, because like, from an engineering perspective, as someone, I've, built, some baby MCP servers, and it has come a long way in the past, like 8 months for sure. Things are improving. There are still things that, in terms of scale, right? Like a server is going to be limited by the strength of like the LLM you're using, because it might only be able to call so many servers at once. So there's a lot of different interesting limiting factors when you're thinking about getting to that point that David is talking about. But I think that that's where, now that the main buzz of MCP has sort of begun to pass, that's where the work has been going.
And Sally, I had a question for you, from an engineering standpoint. Obviously, I'm sitting at the use case development and ROI. How does it benefit a customer in bringing an MCP type solution? A question for you would be, as when I started looking at the design that Meta and Google and Azure, how they're looking to architect it, right? Some of the architectures are a little bit different than others. One of the things that I have a question is about the memory management of this context, right? How much of a memory they want to place, how fast they want to have that in memory, from an access standpoint, from a inferencing standpoint. What do you think about how that would be designed from a dynamic and static context management?
Yeah, I mean, I think again, it's the answer is, it really, right? It's going to depend sort of on your use case and on your goals. And when I say on your use case, part of it is going to depend on, like, okay, like how many servers are you calling, and then how many tools does each server have? Because the more you have, like, probably the more memory you're going to want. And um essentially also, right, like, again, you are really limited by your LLMs in certain cases. So I'd almost argue, I haven't looked too deeply into those architectures, but this might be a place where I would want to use A2A, and instead of trying to scale horizontally, see how many tools and servers I could pack in, see how much I could increase my memory. That's a horizontal. No, that's a vertical scale. Sorry. Instead of scaling vertically and just trying to pack in more of that, I would almost say, well, why can't we have one agent have this specific task and this agent have this specific task, and sort of link it out more horizontally, so you're sort of spreading out the tasks you're trying
It's like a
to do.
distributed kind of approach.
Yeah,
Okay.
that's, as an engineer, when you're dealing with, I have to keep increasing memory over and over again, whether you do it the way I suggested or another way, the first question is, how can I make what's a vertical scaling problem become horizontal?
Yeah, I think that totally makes sense.
So I'm hearing you both mention servers often. So how much more compute is necessary here? How much more cost is this going to add if we're talking about dozens, hundreds, or thousands of servers needed to execute this strategy?
So to sort of backtrack and make sure I clearly define what a server is in an MCP context, right? That is the sort of package that contains all the connections to the tool. So you might have like a server that connects to a Postgres database. That's just a SQL database, and it might have different tools for different queries, different calls you want to run. It might just have a general query tool, a specific query tool, a add rows tool, whatever it is. And so those tools would all be packed into a server. And so when I'm thinking about compute, I guess there's like the compute that's the server is running, and then there's also the compute that the LLM is running in order to talk to all of these things. So it's almost it's a tricky thing to talk about, right? Because yes, if you're running a bunch of different processes on a bunch of different servers, you're using all of that compute, but then also the more complicated of a network you have, if you have a bunch of agents talking to each other, those are tons of LLM calls you're sort of generating. And so that is a downside of like one of the solutions I proposed. I don't know if you have anything to add to that, David.
I mean, what I would add in that, just giving a perspective would be, is that it would be something like, if you look at Atom, just getting back to Atom, right? So Atom is now connected into Salesforce, it's connected into ServiceNow, It's connected into, all the other information repositories at worldwide, our platform, our web pages, all of that, right? So the point that Sally's making is those are servers in a virtual sense, but they really don't take the type of compute that you may be thinking about. Where the compute really comes, in my viewpoint, would be the memory allocation to actually generate the context in this case. The vector databases where you're storing the vector representations of this information, so you can quickly search a semantic, like the Facebook similarity search as an example, and some of the other vector searches, your RAG applications. Those are where the compute. And then when you look at a Blackwell architecture, right? Why does a Blackwell architecture start to benefit is because of all the networking capabilities from GPU to GPU, rack to rack, all of those things. That's where the compute really would speed up the response of the system. And hopefully I'm making sense there, Sally. So that's kind of what I'm thinking.
I think you said that far more specifically and eloquently than I did. So really, that's a really good breakdown, I think, of where the compute is really coming in.
No,
but
yeah, go ahead.
Just to hammer in on that point, like from what David is saying, right? Then the more like, servers and various integrations you're adding and those types of things, like that's where the compute is scaling up. So I do think I wouldn't say it's linear, but yes, the more integrations you have because of all the things that David mentioned, you're going to need more of those to support your application. And that's where, the size does balloon.
Yeah, Sally, I do want to talk a little bit more about integration, and David, feel free to weigh in as well. Where does MCP and A2A fit alongside existing, how enterprise IT teams support AI? Like, what does this do in terms of, some of the API gateways that we've been using? Does it sit alongside? Does it replace? Are we talking something differently, or is it a disruption?
I wouldn't say it's a disruption. I would say that there is going to always be something I would encourage all enterprises to think about is there's going to be some initial lift because likely you already have agents that know how to call tools, and integrating an MCP server is going to rip out some of that. But that's like an initial down payment basically, because once you sort of have your agents running so that they can talk to other agents, or so that they can call other MCP servers, then it's much, much easier to integrate from then on. So there's a high lift at first, but then I think it goes much better from there. And then also, I think the gateway end, if your gateway is calling an agent, right, like that integration shouldn't be touched at all. So I would say if you're interested in integrating it, you should be prepared for time to be upfront. That's the cost. And then it'll save you tons of time on the back end.
And upfront, what needs to be taken into consideration by some of our client organizations, or any organization for that matter, looking to explore these methodologies?
Yeah, so there's a few. One, like I said before, you're just going to actually have code-based changes, and that's going to take time, and you want to test anything that's going into production rigorously. I think another thing to be concerned about and thoughtful about is security. These are very new practices. And so I know that MCP and Anthropic, who again is behind MCP, has just been coming up with, better ways of running servers. So for example, they don't store your metadata and things like that, but there also have been vulnerabilities in certain servers like the Slack one. So you would want to sort of evaluate those things, make sure that the tools that you're implementing also are actually authenticated properly. That's going to be a little bit of a bigger lift up front as well. So just in regards to that, production level, we can actually put this out in the public and it won't leak our secrets kind of thing. There's going to be a little bit of a lift there too, but it's already, from when I first started thinking about MCP to now, it's already gotten a lot better. So I can only see that improving.
This episode is supported by Glean. Glean is the work AI platform that connects and understands all your enterprise data to generate trusted answers and automate work grounded in company knowledge. Put AI to work at work.
kind of come back to the interoperability question, right? I mean, the reality of all of this, right, and Sally can kind of chime into it, is that we live there. Legacy systems are going to be there, right? It's not like just because we brought in MCP, suddenly we lose all the legacy information. So the way I see MCP is actually to the advantage that it's a great interoperability sort of platform, right? So you can connect legacy information as well as brand new information repositories together. And that really benefits, if designed correctly, can benefit the organization tremendously. And my background is been in 30 years in healthcare, designing picture archival systems, quality management systems, enterprise document systems, all of these things, right? And so when I look at MCP, I'm like, oh my God, how great would it be to connect all of this information sets? Because at the end of the day, they're all an ecosystem that has some relation from one to the other. And if you just look at a clinical IT example in a healthcare organization, right? A patient walks in and, for some reason they're having a problem, right? So you get a diagnostic, right? You get a diagnostic or the image that then goes into the picture archive. Well, then the physician may ask for a blood test. Then they may ask for this. Then they have an electronic health record. And then they have a visitation appointment, right, as to what's happening next. Then they have a drug that is provided to them, right? So that's a pharmacy. So when you look at all of this information, they're all disparate information, but they're all connected to the patient, to the physician, to the administration, to the insurance, all of this. Well, if I had an MCP, if I structure the interoperability correctly, I can query all of that in a fairly quickly manner without having to take a time. Like, it's very siloed today. So these MCP and agent to agent can really help not only bring structure, standardization, but also the quickness, the automation to get the patient at the end of the day the right medicine at the right time. So that's how I look at it.
I think your vision is the correct one. Maybe if we even wanted to dig into that a little bit, David, and talk through what that would even look like as an example, right? So you're talking about there's tons of different systems you might need to query and stuff. So, you can think of each database as its own server with its own integration, and then maybe organizing, on a larger level, you'll have different agents have access to certain different databases, and then connecting them all with one host agent that can talk to each one of them.
Absolutely. So if you look at the electronic health record system like Epic, for example, it's still pretty siloed, even though information is pretty standardized in them. Right now, the way I see Epic, for example, is you can search information, whether it's an X-ray, whether it's a blood test, whether it's a lab, whether it's genetics, all of that, right? But the true aspect of an NCP and then AI starts to come in. What if the physician, just before seeing the patient, runs a query in a prompt saying, hey, what is going on with the patient and what's his history? And immediately it brings about a very summarized thing saying, hey, 10 years ago, they had an accident or whatever, they came in, they did a blood test. These are current stats. By the way, they have a wearable monitor, and so far we don't see any problems. So here is some of the suggestion based on the large language models are already trained with that data. You're giving context with the model context, and then you get the answer. And by the way, now here's a prescription already. Here is the next steps. Here is the next appointment, 2 months down the line. Wow. Like you're really starting to talk about efficiency there. That kind of Sally, what you were thinking? Sorry.
Yes. Yeah, exactly. I was even thinking more granularly for each one of those tests. You might have a different database server. So I was really digging into the architecture, but I think, that's a great example of what we want Gen I to take us to.
Yeah.
Yeah, I love the real world application there. I'm curious, is that an actual real world implementation, David, that you've been working on with clients? Or maybe walk me through a little bit about what you're seeing in terms of adoption, or where it actually sits in reality in terms of making its way into enterprise.
So I am seeing that, but in pieces. It's not all there yet because healthcare has always been behind. purposely. They're very risk averse in how they bring technology.
Sure.
Whereas, the likes of a Meta or a Chat GPT, they're much more faster just because it's an interaction for customers. It's a lot more free flowing. Whereas, like if you look at healthcare and some of the like finance sector, they're a little bit more risk averse. Like they want to make sure that the integration and the technology actually don't make mistakes. In making a decision, especially with the agentic aspects of it. So I think that's kind of, but I am seeing that progression, I would say. Is just maybe a little bit more time, and we are working with a lot of customers that are looking in that direction. And so part of our group, the AI advisory group, is how do you take the generative and the pre-generative AI to agentic and physical? How do you make those steps? And a lot of that comes back to one of the fundamental things is how good is your data? That's where it starts, right? How good are your tokens that you are measuring and processing, and how good is your inference going to be? But if your data is quality is poor, and that's why, like you look at Adam and Worldwide, they've done such a great job because the data is really good, right? The approach is already good, so you can build things on top of it, just like a foundation. So that's kind of my feedback.
Yeah, I like how you say you're starting to see it more in the enterprise setting. I'm curious, of those early adopters, David, where are some of them finding, bits and pieces of momentum, and where are they faltering a little bit? What are some of the warning signs that others should be looking out for?
I think places where they're really looking to use AI and using as one example where drug discovery, like J&J, AbbVie, some of these companies, this is where they're really putting, especially new chemistry, biochemistry designs, protein structure designs, drug formulations. They go to thousands and thousands of formulations, and in the past that would take months, years to develop this. And now with the AI, especially with how quickly you can generate new ideas and designs, that's a great acceleration that's happening, right? Is it in full blown, process? Not, but I think it's starting to get there. At least from a healthcare standpoint. Another area I would say is like supply chain, what I would call as finance area, like fraud detection, even like telecommunications with network operation centers. Worldwide has taken a great lead in that area based on what I'm seeing. So those are some of the areas where I've seen how AI can truly be beneficial. And maybe Sally can add, what do you think are some of the other things?
Oh, I mean, I was just going to say, I mean, from my perspective, I work in management consulting at WWT, right? And I would agree 100% with those, and especially I think with like, communications and just anyone who's dealing with networks, predicting outages, that kind of thing, summarizing that data quickly, that is somewhere where I have certainly seen an uptick of interest and potential adoptions. So
Sally, I'm curious from an engineering perspective, are there any warning signs or hiccups or lessons learned that clients, if they're looking towards adopting MCP or A2A, that they should be aware of or looking out for as they go along that journey?
yeah. So I would honestly go search for there's like an 8-minute YouTube video about like MCP Slack vulnerabilities. And I would go check that out and see how, like, there can be in a server, especially if you don't write it, then there can be vulnerabilities. One of the advantages is you can sort of take a server anybody's written and not have to write that code yourself that integrates into the tool you want. The disadvantage is if there's a vulnerability in that tool, then like you could be exposing potential data. And it wasn't even malicious, right? So I would say the very first thing people should think about is security and making sure that they have the resources to deal with that correctly. Number one thing I would say.
Sally, I think that's a great point, and I think that's where what I've been in recent discussions with NVIDIA and using their kind of enterprise architecture framework, right? They provide the guardrails, they provided the validation models, they're providing the scalability elements, how to structure the storage and the models and all of those things. And so you do need a safe environment where you could run this to kind of prevent what Sally is kind of mentioning. Because again, like I said, how do you know that this model and this architecture and framework is secure, right? That's one of the critical things that you have to make sure it's right. And so that means that you need to have somebody, a third party that needs to validate that or provide some sort of a registry so that that's kind of safe, So I think it's a great point, Sally, that you're making.
Yeah, I love the fact that you guys are bringing security into the conversation here. Is it, and we can bring security experts on and talk about this if we'd like, but just from your perspective, what security considerations should we be talking about? Is it back to the basics, just access and visibility and things like that? Or what types of security solutions are needed to make sure, David, to your point, that these are running in a safe environment?
Well, I think you need to have the general security of, making sure your data transactions are encrypted in some cases. Because a lot of the information could be IP related that you are trying to get responses to. You need to have guardrails so that information doesn't get, pushed out into an area of discussion that you're not really supposed to talk about, or that the responses can lead to other hacking, efforts, right? And so there's several types of security at the basic level, your internet security, and then your prompt security, your LLM security. Are the models in a valid state? How were they trained? What are the responses? All of those things need to be kind of addressed as a holistic. But yeah, I think that's what I am looking at when I look at a framework.
And I think David's dead on the money, and I think guardrails is the thing that would really help with the vulnerability I was talking about, right? But something, just to even add on to that, there's also just the integration perspective of security. So to go back to Data's healthcare database sort of example, say, a doctor has certain amounts of access, or different doctors have access to different, databases based on what they need or something like that. So at the server level, again, right, this is what's connecting to each database in this example, each tool. You'd want to make sure that the correct authentications are leveraged for each server. And there are, an increasing number of ways to do this, but it's just something to think about when you're building is, right, not just the security to authenticate to the LLM itself, but, how can you make sure that this person is authorized to access this particular tool, this particular, server. So that's another consideration when you're integrating many different things.
Yeah, that's a great point, Sally.
Yeah, and what brought that up, Sally, your initial vulnerability was just talking about, if you're not writing the server, you're not exactly sure, what the vulnerability might be. That makes me think, are we going to have a whole kind of server economy here where a lot of, there's going to be a lot of vendors or solution providers that are writing their own servers? Is that going to be something that pops up, or is it already a thing?
It's there. And there are a lot on the internet. I mean, I've used a lot too. And like I said, there have been changes so that now it's not, they're not storing any of your metadata. So I would say it's, if a server is verified to, follow all the model context protocol rules, it's safer to use now than it was even like a few months ago, right? But yeah, there already is an economy, but at the same time, something else that I've sort of seen, and this is sort of almost a segue, but it's like, okay, like there might be a server to interact with this specific thing, but it doesn't have the tools I need. So I'm either going to need to use the tools it already has to add it to the server, customize it a little bit or something like that. So I think that there's like a lot of flexibility and variability around that.
Yeah. And Sally, I think one thing I wanted to get your perspective would be, I thought that also, obviously there are going to be some sort of standards that going to start coming up with the security side, right? But I think explainability, that especially with the Atom, how it builds citations, right, to specific information that it pushes back on, right? The explainability aspect of it is a way to secure, it's a secure design to me, because if I just put in a prompt and say, hey, what's the answer? It spits out an answer, but without any explainability, that immediately, I need to do more scrutiny around it. But if I had explainability saying, hey, here's my answer, and these are the reasons why I came up with the answers, and here's the citation to specific articles or the database or a customer ID or whatever it may be, I think that builds more, secure elements to how I've designed the MCP for that matter, right?
Yeah, I think so. I think explainability is a really important part of it. I think that, and again, as you were the one to bring up guardrails too, super important. How do I know that I'm not getting prompt injections in this server I found, and those kinds of things, and maybe even honestly, maybe a way to test them. Before you plug them into prod solutions, I think that would be, or prod environments is, silo it, put it in a Docker container, so, other environment of your choice, and make sure it can't touch anything, and test it out.
Well, recognizing this is, relatively new still, do most organizations have the people to manage this, or are they going to need to train or hire, or is it something that potentially AI can do for itself?
At least in my article, that was one of the big challenges, honestly, is that, the architecture, the engine, the concepts and the frameworks are there, but you also need the appropriate engineering teams that can put this together. So they do need to understand the aspects of what does a context management mean? What does a vector databases mean? How do I apply servers? How do I structure the servers? How do I implement agent to agent distributed approaches? You need to have the right workforce that understands these concepts, to be able to pull this. So it is a challenge that the companies will face as it starts to progress, in my viewpoint.
Yeah, I mean, I think the solution to this is just clone me several thousand times and hire me at every org. But
Absolutely, that makes total
yeah.
sense.
I will say though, more on a personal, note, as a machine learning engineer, I started as a data scientist. I think it's a pretty common path, and you are seeing, there are definitely many cases where, having a pure data scientist is super undervalued, someone who just really knows models and algorithms well. But I think you are seeing more of a shift towards many data scientists getting better at like sort of the engineering side of things, and many roles looking for someone who can sort of straddle the line. And I think that transition will also help what David's talking about, is that, like, again, not for everyone, but like sort of right now, what I do, NL ops, is very niche, and the less niche it becomes, the better prepared the workforce will be to sort of deal with this kind of thing.
Yeah. What about moving forward? What's to say that there's not going to be another DeepSeek moment or something similar that would put this all kind of behind us? Is MCP, agent to agent, is all of this going to be relevant when the next big rollout comes around, or is this going to be a consistent part of our future and strategy?
Well, when A2A came out, it didn't throw MCP out the window, right? So I would kind of say I think the reason it might stick around, and I'd be interested in David's perspective, is it's not truly, like it's not like a model, right? It's not like DeepSeek's a model and a different way of making an LLM. It's just a protocol. It's just a standardization. So unless someone comes up with a better standardization and then also generate the same kind of hype, like one of the reasons MCP and A2A, like what will make them successful, what's making them successful so far is that adoption, right? Like that's the sort of soft part of it that you have to get it to work too, because what's the point in having a standard if no one's using it? So from my perspective, I think that that's a huge hurdle, but I could certainly see things, what I don't know, but things coming out that like, takes away the hype from them and makes it more about how do we integrate this new thing with systems that already have those. But
Yeah, I would agree with you, Sally. I think I would say MCP will actually mature a lot. And we can see, right, like as you had the basic internet, and then you started to have websites, and then you started to have we started moving to the artificial intelligence, and then AlexNet came in 2012, and that made a big shift because of computer vision and how it saw it. And now we are at the MCP after large language models. So what I would say is that it's only going to mature and become more and more sophisticated and intelligent. But there will definitely be, in my viewpoint, the direction into what they call as physical AI that we are talking about. And then the question really comes is, how would we advance like sensors, for example, taking raw information that you're seeing or hearing or visualizing, or you're sensing, touch, smelling, all of that type of raw physical data. How do you channel that to the likes of a large language model, to the likes where, how do you interpret that information, which will become key for AI to really succeed at that next level? And it is only going to be seen, but that's kind of where I see the big transition. And I just don't know how quickly that's going to happen. And then you can also look at the quantum computing aspect, which, how do you really kind of scale that? That's what the interesting aspect to be. Once the quantum compute, the compute thing gets sophisticated, then it's going to get implemented into the AI, and then what happens, right? So that's to be seen.
Yeah, lots to consider moving forward. Well, I know we're running short on time. David and Sally, thank you both so much for taking the time out of your schedules today to walk us through what I know is on top of mind for many of our listeners out there today. So thank you for joining.
Sure, absolutely.
My pleasure. And I'd just like to give a really quick shout out to our intern, Vasu Khanna, who taught me a lot about A2A and wrote a great article on WWT's website about it. So check it out.
Absolutely. Okay, before we sign off, there's 3 things I hope stick with you from this conversation. First, the handshake matters more than the hype. Think of it this way. MCP puts every scrap of data and every tool your company owns into the same shaped box. The A2A protocol is the courier service that moves these boxes between agents. When those 2 standards click, you don't rewrite integrations. You just pick a box, pick a courier, and let the work move. Second, security is a day 0 decision. Sally's warning was blunt. An unvetted MCP server is basically a vending machine for your crown jewel data. Encrypt every hop, every sandbox, and every log off that they hand off. And third, talent is the real throttle. The frameworks are here. What most firms lack are the engineers who can wire them together. So start small, 1 use case, 1 KPI, and give your teams time to learn the new plumbing. That's it for the AI Proving Ground podcast this week. This episode was co-produced by Naz Baker, Mallory Shafran, and Kara Kuhn. Our audio and video engineer is John Knobloch, and my name is Brian Felt. Thanks for listening, and we'll see you next time.